So we wanted to talk a little bit about drawing these graphs based on limits, and sort of a little review concept first is the idea of what makes a graph a function. And you may remember this from Algebra 2, something called the vertical line test. So when we've got a parabola, um, this is a function because when I give an input in the function, I can always find exactly one output. There's never any confusion. So whenever I have one x value, there's exactly one y value. And so we call this the vertical line test because no matter where I draw a vertical line, the the vertical line will never hit the graph more than once. And so a parabola is a function. A circle is a perfectly good graph, but it is not a function because when I pick lots of x values, not every x value, but lots of x values, it hits the graph at two different y values. And so that makes it a little confusing when x is whatever, or when x is 3, what is y? Is it this one up here or this one down here? We don't know. And so whenever we're doing this f of x stuff with the limits, we always want to make sure that we actually have a function when we're done. And so pretty much everyone who was doing that little activity where you looked at someone else's graph, everyone was doing a very good job with the calculus. It was just the final little piece of the puzzle um, to make sure that you actually have a function at the end. And so let's look at this one together. So good little review here. The limit of f of x as x approaches 2 from the right is 3. So I'm going to go over 2 and up 3. And I know that I'm getting close to that point. I don't know what's happening actually at the point, but I know I'm getting close to that point. And so what I would do is put a little open circle there, and then I would put a little tail here, um, and just to remind myself that I'm approaching that open circle from the right. Let's zoom in here a little bit. What about from the left? Well, as I'm approaching 2 from the left, I'm actually approaching a y value of -1. And so now I'm going to have this open circle here and a little tail coming off from the left. This last line is not calculus. This is just good old function notation. It's telling me that f of 2 is 1. And so that puts the closed circle there. And again, what people are doing a good job on this part. They're getting the dots in the right spot. The open and closed circles are looking good. What about this limit? This is a two-sided limit, so as x approaches -1 from both sides, we have y approaching 2. And so we have a hole there, both sides, with lines on both sides of it. And then f of -1 is -3, and so that's going to give me that closed circle. And so these are sort of the pieces of the puzzle, and what the common mistake was people just sort of took these tails and just sort of extended them and put arrows on them. And so on the left and right, that's totally fine because the graph can just keep going, and we don't really care if you draw a straight line, a horizontal line, you draw a squiggle or whatever, just as long as it's a function. The problem comes in this middle section where what some people did, which makes sense, is they just sort of went, and like this, and just sort of added those arrows in. And now we've got a problem because now all of a sudden we don't have a function anymore. If these arrows keep going, this graph keeps going, we're going to have lots of places where the vertical line test fails. And so now I have all these x values where there are two y values. And so how do you fix that? Well, we just go back to my little tails here. And basically I just connect them. And again, we don't really care if you connect them in a straight line or more of a curve. Doesn't really matter for this problem. It just matters that it's hitting those right open and closed circles. And so now we're good, right? This is definitely a function. It passes the vertical line test. No matter where I draw a vertical line, it's just going to hit the graph once. I don't have any closed circles overlapping. That people are doing a good job on that, but sometimes people do make a mistake on it. They'll put a closed circle on all of these. That makes it not a function, right? So the limits generally tell you where you put the open circle. The function tells you where you put the closed circle. If you end up with a closed circle on top of an open circle, that's fine. The open circle basically just gets filled in, and now it's a closed circle. Hopefully that helps. Keep up the practice. Everyone's doing a good job.